Hi friends, today we go here. Last class we seen about 3D modeling and everything. So today we're going to see about the assembly. So what happened when we import assembly file and how we have to constrain and how to machine. So these are we have going to see in this session. So just drag and drop an statics actually here. Okay, okay. Now her name is assembly. I'm going to just import in model. The right click and import geometry browse. So in this session I'm going to import so benchwise. So last class seen about the geometry. Now we directly move on model here. And model, so double click there. Okay, still open. So assembly sum is a rare condition, but we have to know what are the criteria and what are the steps we have done in the assembly section. Okay, it's opening now. Almost complete. Yeah, okay, almost complete here. Okay, allow aux. Okay, it's a bit slow. Okay, now downloading. Yeah, now we get the model here. So I turn off the vertex, a lot of the point. So I go and turn off the vertex here. Now you can see the my assembly point here, total assembly. So what an assembly? First of all, click the geometry. You can see the all the part here, so individual parts. So what we can do is we can change the material for each and every part as we like. Add different part and different materials like here. So then here you can see a new folder like connections. So it is generally new and click that one. You can see here contacts. So contacts means the nothing but like a mate. Okay, select anyone here and okay, I select first one, then you can get some idea. Okay, I selected here. Now you can see the two body here, contact body and target body. So this two you can see here from where you can exactly contact here the blue and red. So nothing but like mate. We made in modeling software the same as here, but in this case we have to define which type of mate is this. In, for that we know we have to know about welding and bolt and nut everything. So like that we can see the type here bonded. So bonded nothing but say we can with the bolt or weld. We can't remove that one. So like that each and everyone has different part. When we see this two part, we maybe has slide. We can check where it is okay. In 26 you can see this the two face the red color and blue color. So these are the frictional region. Okay, because the target body is move here, so we can change here to frictional. The target body move around the contact body, so they take the frictional, we change the frictional values. So like that we have no separational. So now separation nothing but like hinge type. We fix in the door. One end is a fixed and other one is a free, like rotations. So this is called hinge type. This is no separation. Like that we have different models. Okay, has same as like frictionless, rough or frictional mainly using like bearing, like ball bearing. In ball bearing, the balls are friction, but there's less friction. So naturally, so we can say it's a frictionless. Like that, we have rough, forced frictional, and frictional. So these are related to frictional values. Okay. We have note to the values here only. Okay. So in case I change the frictional, so I have to enter the frictional coefficient for the bodies interact. Okay. So these are the one part, like that we have to contact each and every one. Okay, then go for mission. We already saw about 1D, 2D and 3D mission last class everything, and also global and local mission. Here we can clearly see about global and local missions. Okay, because here is a number of bodies more. I first of all give the local global mesh here. So generate mesh. Now I simply go the global mesh. Then I go for local mesh. You can see the difference between these two, how it's perform. Okay, almost going to end 8, 9 and finish. Okay, now you can see the mesh. All are the same type of mesh and same type of the value here. But the two surface are frictional. I want them different meshes. Okay, so that what we have to do, we can go for the local mesh. So mesh insert, and I give first method this one and this one, because these two are frictional values. Okay, I give for hexadomin, and I next I'll go for the sizing. The same I have to select that these two, and sizing has maxes 7. Okay, then mesh, generate mesh. Okay, so this is the main important for local and global meshing. We have assembly part, but some part only we have one fine mesh, so that mainly we can use like this. Okay, just wait, you can see the result few seconds more. Okay, almost done. Okay, now we can see the difference between these and these. We have purely hexa dominant, and the mid size are the 7, but rest of the parts are there's irregular shapes and irregular meshes. So this is the main purpose. We go for the local and global meshes. Okay, next here we go for the connections. We insert also joints, spring, bearing. We can insert these two all. So joints are nothing but a crane. There we can use the joints like that. So we can also use bearing and spring like that here. Okay, in case we're using the bearing means just select bearing, and we can go the stiffener values and damper values, and then select the scope. I select this type as a rotation and which plane. Okay, this plane has rotation and scope bodies and scope. I selected the scope. Okay, first of all go the scope and select this face and apply. Okay, now you can see the bearing here. You can enter the value here. Okay, first of all give the, or you can make the coordinate system by making a 0 0, or in case I want some center, this face belongs to this that region only, so I go for the face, this two face and enter. It's not okay. Now it's apply. Just go for, yeah, now you can see it's an exact center. And now I go for this scope, the two face, and give the body. So I select the body, it's fit to the bodies here. So like that we can change this wherever you want, we can make the bearing. Okay, and also enter the value here. In case I want to change from this face means click the face and select enter or apply. You can see that stick with that face like that. What where we want bearing means we can directly import our bearing here and with some properties here. Now we go for the spring too, like that spring and everything, or now I insert some spring here. Okay, here we have mentioned the longitudinal shift and damper thing. First of all I select this vertex here, this is our scope, and I center build scope in there, this position, and select. Okay, now I have entered the stiffener value 45. It is random value, you can enter as your own value. Now you can see the two bodies and the vertex here point. This is the spring condition. Like that we can import spring with the body to body, or this is body view, this connection. Okay, like that we can insert spring and everything in assembly part. Okay friends, like that we can import as a ground to body and ground body to body. Here ground to body you can see the same spring, and body to body the same everything. What difference means, when ground to body means we fix only with the ground surface, and body to means it's a two interact with two bodies. But is same as a fix rotational cylindrical transition is same as we done as assembly earlier, like modeling software. The same procedure here also we can insert as same that, and we can done some analysis with this. Okay, these are the major thing while we done in the assembly part. Okay. Yes, so this little bit explanations about the assembly. Okay, so like that we can fix and give which type of force we have to add, and which direction we had. We can have same we done in the 3D model, we can give the force and pressure here. Okay friends, from here onwards we complete the static section with the 1D 2D and everything. Okay, next we move on the some of the different subject like vibration. So then we go for the like thermal. So these are the next processor and next steps we have to go into that. Okay friends, bye. Okay, see you next class.